Hello everyone, and welcome to today's chem lesson. Today, we are going to be introducing some of the ideas that are going to become fundamental in our ideas about our understanding of chemical bonding. Moving forward from the ideas that we looked at in our last unit of the periodic trends and the periodic table and the way that it is set up, we're now going to take a closer look in at the interactions between elements. When two elements come together and interact, the thing that we are hoping happens, or the thing that we are looking for, is a bond. And a bond is formed when two or more atoms come together and either share or transfer electrons from one to the other. And there are three types of bonds that we are going to look at over the course of the next couple of videos, over the course of this unit. We're going to look at ionic bonding, covalent bonding, and metallic bonding. Each one of these three types of bonding is different. Ionic bonding focuses on the transfer of electrons. Covalent bonding focuses on the sharing of electrons. Metallic bonding focuses on a more intense pooling of electrons. And we're going to spend a video looking at each of these types of bonds to learn more about the way these work. But the way we tell what type of bond is going to be made is largely determined by a number called the electronegativity difference. Electronegativity should be a word that rings fairly familiar to us at this point. We talked about electronegativity in our last unit, and we defined it as the ability of an atom to pull on electrons, to pull on new electrons specifically. A high electronegativity means that the atom is good at pulling at new electrons. Low electronegativity means the atom is bad at pulling on new electrons. And really what this becomes is a kind of strength check. The higher the electronegativity, the stronger the pull. The weaker the electronegativity, the lower the electronegativity, the weaker the pull. And so when we talk about an electronegativity difference, we're looking at the comparison of two atoms' electron pulling strength. We're looking at the ability of these atoms and checking to see, okay, are they equally strong? If these are having a tug of war, does one of them win? Are they closely matched? And we're using that data to help us determine and figure out what the differences between them. Now, the other important thing that we should address is the fact that table S exists. Reference table S lives up at the bottom of the table, and it's this really long multi-page piece of the reference table. And a really interesting thing that exists on table S is the fact that all of those trends we were looking at, ionization energy, electronegativity, atomic radius, all of these trends are listed, and the data is listed on the periodic table. So instead of having to look at the periodic table and say, I know electronegativity increases as we go up and to the right, I can just look at table S and have actual numbers to compare two elements. If I wanted to compare nitrogen and oxygen, 3 to 3.4, oxygen has stronger electron pull than nitrogen does. And that information is listed here and given to us on the table. It is a little tedious to have to look up a bunch of different electronegativities, so it's important to still understand the way the trends go and why the trends act the way they do. But in any case, if there's ever a question in your mind, you can always come and look at the reference table, table S, to find these values. And so, when we look at the electronegativity difference between two atoms, we're trying to find out if that value is greater than 2 or less than 2. And the idea behind that is that if the electronegativity difference is greater than 2, if we have fluorine, which has a 4.0, and compare that to something like lithium, right, which, let's use table S. Lithium has an electronegativity of 1.0. The electronegativity difference is 3.0. We're going to take the bigger one, take away the smaller one. Since that's 2 or more, that's going to tell us the bond is ionic. Now, what does that mean in easier, simpler, non-technical terms? This means that when fluorine and lithium come together, fluorine is going to take an electron away from lithium. Fluorine is so much stronger than lithium that it's not even a tug of war, it is just straight up theft. Fluorine is just going to steal lithium's electron because it has a so much stronger pull. Because electrons have been transferred from one to the other, that classifies this as an ionic bond. Whenever the difference in strength is greater than 2, that means it's strong enough for the stronger to just take from the weaker. If we look at something a little bit less differentiated in strength, right? Oxygen with a 3.4 compared to hydrogen with a 2.2. The electronegativity difference here is 1.2. That is a number less than 2. That means that this is going to be a covalent bond. And essentially what that means is that instead of an electron being transferred and just taken away from the hydrogen, which is the weaker one, we're going to actually have a tug of war over the electrons here. Hydrogen is going to pull on oxygen's electrons. Oxygen is going to pull on hydrogen's electrons. And they're just going to live in this tug of war. It creates a very different vibe than a ionic bond does. Where an ionic bond is a pure transfer. Lithium loses an electron, fluorine gains an electron. A covalent bond deals with both elements pulling on the other's electrons, making this tug of war and kind of attaching them together due to this tug of war that's going on. One can't go far from the other because they're both pulling on the same things. We're going to start off in our next video talking about ionic bonding. Ionic bonding, because it is kind of cut and dry, it is a little simpler to understand. It's a little bit easier to work with and to start getting our minds around these concepts. But for now, talking about electronegativity difference, we're looking at comparing these values that we know off the reference table S, finding out the difference between them, and seeing how that relates and how that, bounces back on the strength and sharing versus taking of electrons. I'm actually going to leave us here for now and transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.